Hi guys, Lou here again from Cianci the Math Tutor. Thank you for coming to part 2 of this video series on demystifying the distance formula. In today's video, we're going to go a little deeper and try to use our mental math to uncover some of the mystery. I hope you enjoy this one. Thanks.
Alright, here we go. Let's try this first example. I'll give you points M and N, which have a lot of negative numbers. And in order to substitute it into the distance formula, we would need to assign values of x1, y1, x2, and y2. And when we substitute this into the formula, this is what it looks like. Wow, I don't like that. That is pretty scary looking. There's a lot of negative numbers. There's a lot of ways that students can accidentally enter things wrong in the calculator, and therefore it will come out wrong. So there has to be a better way to do this problem, and I have a better way. So let me show you. Now, I've mentioned before, I'm a visual teacher. I like to teach things by showing things that can be shown, and this is one of those instances where we have visuals. So let me plot point M and N on the graph and show the corresponding line segment between them. It's hard to count how long that line is because it's on a slant and there's no horizontal and vertical part to it yet. Unless I draw in the two legs of the right triangle, the horizontal leg and the vertical leg. Let's ignore that there is a distance formula for now. I took away the substitution as well. At this point, we have the graph. We have a piece of graph paper. We have a coordinate plane. We have our triangle drawn accurately on the paper. Let's just do some counting. If I count the horizontal length, that's 8. And if I count the vertical length, that's 6. So now we have a right triangle with two legs, one being 6 and one being 8. That reminds me that we can use the Pythagorean theorem formula to solve for that missing side. In this case, it would be the hypotenuse. And in our example here, we need to find its distance between M and N. So since we're trying to find the distance, let's change that C and let's make it a D. We're just changing the variable, nothing different. I'm just making that instead of a C. Let's make it a D because we're trying to find distance. At this point, whether I put the 8 in place of A or B, it doesn't really matter. So I chose to put my horizontal in place of A. So 8 squared would be the A squared, 6 squared would be the B squared, which then becomes 64 plus 36 on the right side. Adding those together gives you 100. So the D squared, or the distance squared, would be 100. And keeping in mind that we have to take the square root in order to remove that square to get that down to just one singular distance, we end up with a distance of 10. So the distance of that hypotenuse, or the distance from M to N, is exactly 10 units. Now there is a very rare occasion where you may be doing homework, trying to find distance, and you don't have graph paper. I'm telling you it's rare because you probably can get some online, or I don't know. You can get graph paper, but especially in the classroom, your teacher's going to have graph paper, so you always should ask for it. But in the event that you either want to challenge yourself or you can't get your hands on some graph paper, you can definitely freehand this. So what I did was I just drew an X and a Y axis. I gave you 2 points, A and B, with some values. Now there's no grid on this, so it's difficult to just count out where 11, -3 would be and where -4, 5 would be. So I'm going to need to just freehand exactly, well not exactly, but approximately where I think these points will be. At least the first point, A, is 11 in the X and down 3 in the Y, so I know it's in the 4th quadrant. And B is -4 in the X, +5 in the Y. It's in the 2nd quadrant. Am I exactly in the right spot? No. Does it really matter? I'm going to show you that it doesn't. The bottom line is you're trying to find the distance between those 2 points. And as I've shown you in the last couple examples, it's just a matter of using a right triangle, using the Pythagorean theorem formula, and finding the hypotenuse length. So we're going to do the same thing right here. So let's just sketch in a vertical leg. I'm not using a ruler, I'm just freehanding that. And let's sketch in a horizontal leg. It doesn't have to be perfect. You just have to know there is a vertical part and a horizontal part to this. Now this next part's a little bit tricky, but think of it this way. If I'm over here where B is, the X value right here at this point is -4. And the X value at A right here is +11. So basically you have 4 here, 11 there. The total distance between them would be 15. And then if we consider the vertical distance, again, let's go back down to here. At A, the y value is -3, and the B value has a y value of 5. So below the x-axis we're 3, above the x-axis we're 5. And adding those two together gives you 8. So now we have a vertical leg of 8, a horizontal leg of 15, and you don't even have to consider whether they're negative or positive. It's just a distance. It has a horizontal distance of 15 and a vertical distance of 8. So again, we're using our modified version of the Pythagorean theorem formula. I just changed the C and replaced it with a D for distance. Let's place a 15 in place of the A and the 8 in place of the B. I'm getting a little off my line here. And excuse me for my dog barking in the background. 15 squared is 225. 8 squared is 64. Add those together, you get 289. I feel like I've used this example before, but it's okay because you might notice that's a Pythagorean triple. I'll do that in another video. But d squared is 289. Taking the square root of both sides leaves you with a distance of 17. So the distance of that is 17. I didn't use graph paper. I didn't use a distance formula. I basically used what we know about the coordinate plane to find lengths of the legs of the right triangle, plug them in, and there you have it. This last example is slightly more advanced, but if you guys can handle what I showed you so far, this should be a piece of cake, because this time we're not going to be sketching anything. We're doing this entire problem mentally. We're going to take what we learned in the last few examples and just apply it, keeping in mind that you do know there's a coordinate plane and you know where the negative and positive values are and where the quadrants basically are. Let's take these 2 points, C and D. Now, we know we basically are going to have a right triangle. I'm just going to sketch one just so you have something to think about. We have a right triangle that has a horizontal distance and a vertical distance. And remember, the horizontal distance are all your x values, and the vertical distance are all your y values. So just keep that in the back of your mind. Okay, so imagine in the x direction, on point C we're at a 7, point D we're at a 2. I don't even care that it's going down in value. It doesn't matter. What matters is we're at 7 and 2, and that's our x value. The distance between a 2 and a 7, you're in the positive x direction. You don't change over any axes, so it's just a difference of 5. Right? You go from 7 to 2 or 2 to 7, there's a difference of 5. Don't even worry about if it's positive or negative. The y distance is a little tricky. I'm going from a positive 8 to a negative 4. Again, it doesn't matter whether you're going up or down. What matters is the distance, the magnitude between those points. If I'm at a positive 8, I'm above the x-axis. If I'm at a negative 4, I'm below. So I have 8 above, 4 below. Total that together, and you have 12. It doesn't even matter whether it's positive or negative. It's just a distance of 12. Then using our modified Pythagorean theorem formula, let's substitute in a 5 for the A and a 12 in for the B. Squaring those two gives you 25 and 144, and adding that together gives you 169. Finally, if we take the square root of 169 and also d squared, we find out the distance between those 2 points is 13. We just did that mentally. We didn't do anything with the graph. We just kept in mind that there was a right triangle involved, and we used what we knew about the coordinate plane, and we did it in our heads. I think that's pretty cool. This is actually how I do my distance formulas. If the numbers are relatively easy to work with, sometimes you're going to have to use your calculator to get either a simplified radical or a decimal, depending on what you need. But in the basic general sense, this is how you do that. So I hope you enjoyed it. I hope these 3 examples helped you understand the distance formula a little bit better. If you have any questions, just post them in the comments. Thanks, guys.
Thanks for watching. I hope that helped uncover the mysteries of the distance formula. I hope you enjoyed it. I hope you got something out of it. And if you did, please share this with a friend, a family member, anybody who might hate the distance formula or is having trouble. And be sure to like and subscribe to this video and to my channel. And I will see you soon.